Hello, am I audible? Right? Hello, please reply. Am I audible? Right? Yes. Oh, thank you. Okay. So yesterday we have discussed about Hugging Face repository and how Hugging Face can be used for our uh, generative AI tasks like summarization or text generation or translation, whatever the data. So how we can effectively use Hugging Face and how we can access data set, different types of data set, even in public or private data set, how we can access the data set and how we can use Hugging Face tokens. So we have discussed about these steps and in this session, I would like to give an introduction about how image generation can be done with the generative AI. I think you are somehow familiar with the different kinds of image generation with Gemini or similar types of LLM. So I think you all are familiar with that concept. So I just want to uh, give a short introduction about how we can create these images and what is the role of and different types of prompts and what is the concept behind generative AI in regarding creating a particular image. So first of all these concepts, whether we are creating images, text, or videos, audios, whatever the content, if you are generating particular data, so it comes under the topic of generative AI. So you all are familiar with the concept Gen AI. So this is the concept. This is the main concept regarding generative regarding the all the tasks like whether it is the data is or creating new content such as images, text, audio, video, code, whatever the data. Instead of just analyzing the data, generative AI produces new data similar to the training data. So that is the concept. Okay, so there will be a model there. So it can be considered as a model, and this model is trained on a large corpus of data, large data. So that's why it's known as LLM, large language model. So it is not just analyzing the data, but it's creating a new content. Okay, it's creating a new content. So this will be the new content, and which is always similar to the trained data. So that is the concept here. For example, there are different types of inputs are available there, like whether we are using an input like text prompt, we can act as text prompt is there. This will be the input. Text prompt can be done. Mm. So the input will be text prompt and the output will be the image. Okay, based on the prompt, we can create image. Also, we can input some sketches. Sketch can be also provided. So based on the sketch, we can create some realistic image. Then we can input images. Okay, we can give images as the input and we can produce edited images as the output. Okay, so also we can give some style description. This will be the input style description. So the output will be a something like a art, styled artwork. Okay, so these are these are the different input and corresponding output that will be available based on the data or based on the trained data set. Okay, so for example, I am giving a prompt like something a futuristic city floating in the sky at a realistic image. So I'm just adding a prompt like this and generating a new the AI generates a new image that never existed before. So that is the concept behind generative AI. So when it comes to the image generation concept, there will be some gradual change for the image. generation. For example, first of in the initial phases, we are using computer graphics. Okay, I think computer graphics will be a topic of study in BCA, BSc Computer Science, even in BTech also. So computer graphics, this is the basic concept behind this every drawing. So traditional computer graphics will be used, and images were created using manual design, Photoshop tools. Then 3D models are available there, 3D models. So there are some limitations with using these computer graphics. So uh, there is a requirement for the skilled designers. So the graphic designers are the most important or most prominent job for a decade for the last 10 or 15 years. But now the scenario is changed and the graphic designing is so easy. So at that time required a skilled designers, and also it's a time consuming task, time consuming one when creating a particular image. Okay, so when it comes to AI-based generation, from the graphics to the AI-based generation, uh, the first step was the use of auto encoders, and then second one is GAN networks, GAN, generative adversarial networks. So this is the generative adversarial network. So this is the two steps. Okay, previously used by AI-based image generation. So these are the two steps that were previously used by AI-based generation. Okay, so now the scenario is changed, and the modern approach was little bit different one. So in modern AI, they are using mainly one is diffusion model, and another one is transformer based model, transformer based generators. Okay, so this is the newer concept used by many of the large language models. Okay, either diffusion model or transformer-based architecture model. So those models can produce highly realistic images from the text descriptions. So the text description will be the key for the what uh, these modern approaches. Okay, so first stage is the graphics designing stage, and the second one is early stage for AI-based image generation. They are using autoencoders, and then nowadays they are using diffusion model and transformer based generators. Okay, so we will discuss in detail about what is transformer diffusion model and what is transformer based generators. Okay, so first of all, I'm assuring that this is not a theory based concept. I'm just explaining a little bit theory, but I will give some demonstration also. Okay, yesterday we have discussed about some demonstration regarding how to implement this in Python library. So definitely there will be an demonstration session. But before going to demonstration session, I just want to clear what are the different approaches and what is the difference between different approaches and what are the core components of each approaches. So that's why I'm just giving an introduction about these approaches. Okay, I hope that everyone is attending, right? Okay, so so generative adversarial networks, GAN is the first concept. GAN, generative adversarial network. So generative adversarial network means which is like a two neural network which is competing each other. Okay, so that is the concept where one is the generator, and the second one is discriminator, discriminator. Okay, so generator will be there and discriminator is there. So generator will create some fake images, and the discriminator determines whether the images is real or fake. Okay, this training will continue. The generator produces realistic images, and uh, discriminator will always try to determine whether the image is what is real or fake images. Okay, so I will give a short explanation about what is GAN. How GAN is working, and there are some applications regarding this GAN-based model, like face recognition and similar kinds of approaches are used. So, which is GAN is a deep learning framework introduced by Goodfellow. I think it's in 2014. So it is designed to generate new data samples that resembles the training data set. So that's the concept. For example, trained with the real human face images, or GAN generate a synthetic face that look like the real. Okay, so that is the concept. For example, here we are training with the training the network with around 1,000 or 10,000 images, okay, which is real images. Okay, so after this training, the model can produce images which is what is not real, which is 100% what is new synthetic faces can be created. Okay, I already said GAN work based on two neural network. One is the generator and the second one is the discriminator. Generator can be represented as G and the discriminator can be represented as D. Okay, this competition, I have already said these two neural network are competing each other, and the competition improves the quality of the generated image over the time. Okay, so in generator network G, there will be an input is the, what will be the input for G generator? There will be a vector representation of the image, vector ആയിരിക്കും. Okay, so the output will be a synthetic image which looks exactly as same as the original one. Okay, uh, the what is the goal of this generator is produce images that look so realistic that the discriminator cannot distinguish them from the real image. So that is the goal of the G network, that is generator. Okay, so the discriminator network will always try to identify and classify real and fake images. Okay, so input will be a real image and output will be probability that the image is real. Okay, so how much probability that the input image is real or fake? Okay, so that will be the output. So the goal of the discriminator is to correctly identify whether an image is real or generated. So that is the concept behind the generative adversarial network GAN. There are different GAN-based approaches like a fake image generation, then some kinds of what applications are there, like human faces, image generation, human faces, artwork, fashion designs, super resolution, image enhancement, image enhancement work like super resolution, and image restoration works are based on this GAN approach. Okay, so in case of medical imaging, MRI and CT scan enhancement can be done with this GAN, but there are some limitations there exists for GAN, like training instability, because GAN training can become unstable, and also uh, there will be a limit for the generators. Generators can produce a limited variety of images. That is the also computational cost is high. So these are the major problems associated with the what this GAN, generative adversarial network. Okay, is it clear? What's the concept of GAN? Hello, is the concept is clear? No reply. Okay, so this is based on GAN concept, and when it comes to diffusion model, most popular model today, diffusion model. So, diffusion model is used in some model, some system like mid journey, stable diffusion. All these concepts are used in diffusion type of model, which is most popular one today. So the concept is we are adding some noise to the images gradually and the train a model to remove this noise step by step. Start with the random noise and generate an image. So this is the concept. This process is called reverse diffusion. So I will show you how we can create a diffusion model. So let me explain in detail about diffusion model. Okay. So diffusion model in detail means it's also a kinds of generative model used to generate high quality images by gradually removing noise from the random data. Okay, so I think you all are familiar with the diffusion concept in physics, where the particles are spread over time. And so that is this main concept here. So in AI, the process works in two spaces. Like one is the forward diffusion, and another one is the reverse diffusion. Okay, so the core idea behind this diffusion model is instead of generating images directly, diffusion models start with a pure random data. Okay, so there will be some random scratches that are there. So start with this random data. Okay, this will be the random data, and start with this random data. They're gradually creating some images based on the random value. Okay, so so this will be a step-by-step process, and the final one will be a good image. Okay, so final will be a, so this is the concept here. So first of all, I have mentioned about forward diffusion. Forward diffusion means we are adding some random noise to the data, and reverse diffusion means we are gradually removing noise from the data. So that is the concept in uh, diffusion model. So there are two major processes are there. Okay, that's why you already said diffusion, forward diffusion and reverse diffusion. Okay. Most of the diffusion models, unit architecture. I think you may heard about unit architecture. Unit architecture is work on diffusion model, unit architecture. Okay, have you heard about this unit architecture? Unit. Okay, so unit is a kind of neural network architecture. Mm, okay, it's a concept of CNN also. I think you heard about the CNN unit and similar kinds of approaches. So unit is based on this diffusion model architecture. Then modern diffusion models combine text also. So that means text understanding also. They can combine text to image. Diffusion models can be created. So we can easily get, for example, a city at the sunset with the flying cars. Okay, so we can create a city there, and based on the text explained in the prompt, we can create the images. So text to image diffusion models are available. Text directly convert into embeddings, and the diffusion model condition generation on the text, and the image gradually forms matching with the prompt. Okay, so that is the concept there. Uh, what will be the advantage of diffusion over model over the GAN is it produces extremely realistic images. Okay, so other than GAN, stable training can be produced, and flexible conditioning like text to image, image to image, style transfer. All these processes can be done easily. So these are the concept with the diffusion model. So film it can be applicable there in some film and animation, digital art, uh, then medical imaging, gaming. All these environment can be simply use this diffusion model. I will show you an example here. Okay, let me open a environment. So, uh, so in order to use diffusion model, we need to import some libraries like from diff users import uh, stable. Okay, just wait for the suggestion. Stable diffusion pipeline. Diffusion pipeline. Okay, so I think we haven't installed this diffusion library. So let me check for the import is working or not. Import torch. Okay, let's wait for it. Okay, it's connected. Okay, so class duplicated and will be removed. Okay, some warnings are there. So before moving into the concept, I just want to change the runtime. So click here and change the runtime to GPU. So okay, so some GPU is available here, T4 GPU. Okay, just click on OK, just save. And before we are going to work in CUDA. Okay, so have you heard about CUDA architecture and what is the need for CUDA? Had you heard about it? CUDA architecture, CUDA, CUDA, Computing Unified Device Architecture. Have you heard about it? Please reply. You all are there, right? Okay, no issue. Okay, so CUDA architecture is provided by NVIDIA, so which is a particular architecture for improving the performance of the GPU. So I will give a short introduction about CUDA architecture later. So first of all, I have imported some libraries. So I just need a model ID, model underscore ID is equal to so stable diffusion can be used and it can be selected from Hugging Face library. So let me check for the Hugging Face library. Okay, I will share the screen once again. Okay, so here we can search for Hugging Face and go to models and here we can search for the model like stable diffusion. Use this model. Okay, so this will be the model ID stable diffusion V1 pipe. Okay, so we are using this model ID. Then going here. So our model ID is, this will be the model ID. Stable diffusion is V15 bar, stable diffusion is V15. So we just need to create a pipe here. So pipe is equal to, uh, we have imported pipeline here. So dot from pre-trained. Okay, we are importing a pre-trained model. So what it can be added here, model underscore ID. Then data type, torch underscore data type is equal to uh, torch dot plot 16. Okay. Uh, so let me check for the whether it is available or not. So it's downloading. It's around 5.48 GB size. Is 50% completed. Okay, so once we have created a pipe, okay, we just need to move this pipe into GPU architecture. So that's why we need CUDA. CUDA is an architecture provided by NVIDIA, CUDA toolkit. Okay, we can see that CUDA toolkit is free of training and provided by NVIDIA. Okay, so CUDA can be easily downloaded and installed from here. NVIDIA providing support for this one. So what is CUDA? Okay, if you are asking what is CUDA toolkit? So it's a framework. Okay, we can see here it's a framework which is supporting different kinds of architecture. Okay, so this is the CUDA architecture, parallel programming architecture. It is provided by rich libraries and programming languages, supported by programming languages, and most of the editors are supporting for this architecture. So we can easily use CUDA framework for architect for using the GPU. Okay, so that's the concept there. Okay, so we have created a pipe here. I just want to move this pipe into CUDA architecture. So pipe is equal to uh, pipe dot two. Okay, pipe dot two. Pipe is moving to what CUDA. Okay, I'm just moving this pipe to CUDA. Okay, let me check for whether it's working or not. Yeah, okay, no issue. Cool. So I'm just creating a prompt here. Prompt is equal to, so I'm just adding a prompt for creating a particular image, uh, a, a futuristic uh, city, uh, floating in the pond with the flying cars. Okay, so this will be the prompt for our data. So I'm just adding this prompt to the image. So we can create image. Image is equal to, we are using a pipe of pipe of prompt. Okay, pipe of prompt dot first image is or 0. Okay, image dot save option we can use. Save like city.png. Okay, we can check here whether city is creating or not. So a city is created. I'm not sure about whether the quality of the image is high or not. Okay, let me open it. Yeah. So this is the image we have created. So let me download it from here. Download. Okay. So this is the image, a floating city and a flying car. Okay. So not up to the level, but something is real. Okay. So this is one kind of approach for what diffusion based model. How we can simply explain diffusion model. For example, if you have a simple explanation regarding this, uh, what is diffusion model and how diffusion model start with the data and what will be the final image. So this is the concept here. So uh, is it clear? Okay, here we have used how Hugging Face can be effectively used, and how we can use more diffusion based model here, and using the pipeline how we can create images. Okay, is it clear? Can you hear me, right?
This meeting is being
Can you hear me? Hello? Can you hear me? 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 Hello, please someone please reply. Hello, please someone please reply. 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 Hello, can you hear me? Hello? Yes, okay. So this is the one point of approach for creating diffusion-based images. You can try with a different prompt. Okay. So for example, different prompt like whatever the prompt you want, you can add the prompt here, and it is, he can create a create interesting image from here. So so I will give you an example for another type of image generation. So this next approach is how we can create images using transformer based approach. Okay, so another modern approach uses transformer architecture, which is very similar to large language model. So examples include DAL-E, D-A-L-L-E, DAL-E, DAL, D-A-L-L-E, then image GPT, image GPT. All these models are using transformer based approach, and so the idea is images are treated as a sequence of tokens and similar to words in a sentence. Okay, we have already discussed about what is tokenization and what is DOP. So I will give an explanation about what are the steps in image based transformer based image generation. So first step is image is divided into small patches. Okay, if we have an image there, and this image will be divided into small number of patches, and the patch creation. So the patch creation is the first one. So the second step is each patch become a token. So we can consider each patch as a token. So token generation will be done, tokens. Okay, so the next one is uh, transformer. That is the next image token. So transformer architecture will be used here, transformer. So that transformer will take one token and it will predict next token. So that's why we can create images based on the token. Okay, so there will be a token one, and this will create based on this one. We will suggest token two, and based on token one and token two, we are such predicting token three. So up to this, and finally we will get a full image. So this is the concept here. So text to image workflow. So we will give a text prompt will be available here, and the text will be encoded, and transformer will use this encoded data, and it will create a generate image. So this is the workflow here. Okay, robot. Okay, I'm just giving a prompt like a robot uh, cooking biryani uh, in a kitchen. Okay, a robot is cooking biryani in a kitchen. The model will generate image tokens sequentially. Okay, so the tokens will be generated, and based on the token, we will create a particular image. So it will mostly work with multimodal data like text, image, audio, video related data. It will work mainly on multimodal data. So it can handle both text and image relationship. So the main drawback is here is that it is computationally very expensive. We can't afford the expense of the computation cost. And the next one is large data sets. We need large number of data sets needed. So these are the common problem associated with this transformer based what image generation. Okay, so I will show you an example how we can create images based on transformer based image generation. Okay, so I have already mentioned that DAL-E model. DAL-E model is not privately, publicly available. So we can use some variations of the DAL-E model, like a DAL-E Mini or Crayon. So we can use it from the hacking phase. So before moving to, okay, let me check for the required libraries. First of all, we need Torch, where we have already imported Torch initially. So transformers transformers import, okay, from the transformer library we need DALL-E, DALLE, DALL-E BART, BART, DALBART processor, PROCESSOR, DALL-E processor, comma, DALL-E BART, BART for conditional generation, conditional generation. Um, okay, so this is the first library. So something happened. Cannot import daily butter process from the transformers. Mm, Let me check for this processor one. Daily processor. So daily part processor uh, from daily mini. Okay, let me install something. Uh, this DALL-E mini library. Okay, so then only I can load the model. So let me check for this whether it is working or not. Just copy here. Paste here. No, it's not working. No module named DALL-E mini. Okay, let me install one. Okay, please wait. I think this library is depreciated. That's why we can't use this one. So this Dalibard library is depreciated and which is not even available in the transformer library. So that is a problem here. So we can see that Dalibard and Dalibard processor is available in Dali Mini. Okay, so this is working. I think this is working. So let me check. Mm, here, new module named Dali Mini. So we can import this one. Pip install what? Dali Mini. We need to install that one. So I think it's working. Okay, this is an interesting blog. Okay, so I'm just sharing this blog detail here. Uh, just adding the blog details are added in the chat. Okay, you can check it there. Um, so Dali Mini is installed. Okay, let me check for whether it is working or not. No, Dali Mini, no module named Dali Mini. Okay, so this is the problem with the transformer-based architecture. So the model, so we are using a limited runtime. Okay, so the runtime type is T4 GPU. It needs some kinds of extensive GPU support, like a G4 GPU or H100 GPU. So that's why we can install this one. Also, it is not available in the sometime it will not be available with this collab environment. Okay, so we need to create a particular environment variable, and then using that environment variable, we need to install these kinds of dependency packages. Okay, otherwise we will get some error like a failed building wheel for tokenizers. Okay, so we can't create a tokenizer approach or sorry tokenization method or something like installation can be done here. So that is a problem here, but you can check that blog, okay, which is clearly explaining about how we can generate images based on transformer based model. So this is one example for transformer based model. Simple example. We can try with a different prompt. We have already discussed about different prompt. We can add different prompt, and based on different prompt, we can create images based on images with the transformer based model. Okay. So unfortunately, I couldn't install these packages in our collab environment, we need a separate environment, either in Visual Studio Code or similar environment we needed. So then only we can install that packages. Okay. So this is one kind of approach and for image generation. So we have already we can create image generation can be also done with some so let us give some examples regarding how we can use effectively and the pipeline method for creating images. So I already said pipeline method. I think stable diffusion pipeline is one example for pipeline based model loading. Okay, so we can create images like this. Then another one is uh, why the pipeline is useful is using pipeline method we can simplify the complex steps like instead of manually handling tokenizer, text encoder, diffusion model, decoder. So all this method can be replaced with a pipeline method. So the pipeline perform everything automatically and conceptually. So we can create what interesting images using this pipeline approach. So mm, any other image creation method? Let me check with. There are different approaches like a neural style transfer approach. Then, so the style transfer means we have some two images are there. So we will have one image is there like so the first image is there. So this will be the first image. And there also a second image is there. So first image has a style S1 and second image has a style S2. So we can create a new image, okay, based on the content in the first image and the style in the second image. Okay, we can transfer the style. So that style transfer method is another type of message image creation technique. Okay, you from the existing images. Also auto methods are there. Autoregressive AR method, autoregressive image generation. Okay, like a pixel RNN, pixel CNN, all these work is are working based on the autoregressive image generation model. Uh, then then So, we have already discussed about what is the role of text pre-processing in case of text generation. So, similarly, we we have image pre-processing methods are there. So, image role of image pre-processing in image generation. So, pre-processing is a critical stage in generative AI pipeline because models such as generative adversarial network or diffusion model and any other model, okay, which requires a clean and standardized and structured data to learn effectively. So, and in these cases, image generation task pre-processing ensures that the training images are consistent and meaningful. So, why the pre-processing is important is input image may be in different sizes. Okay, so different noise effects there and unbalanced data sets will be there. Irrelevant background information are there. So we need to tackle these. This can be lead to poor image quality, unstable model training. Okay, so there are lots of issues are there. So therefore, pre-processing, we can do some kinds of pre-processing to standardize the image to a standard path, and we can remove the noise, improve the feature importance, and training time can be reduced easily. So pre-processing is also important here. So common pre-processing is we can resize the image like this will be the image. Okay, we can entirely resize the image to a new size and image normalization can be done. Image normalization. So pixel values can be adjusted from 0 to 255. Okay, so this is another image pre-processing technique. Then noise removal. Okay, so camera sensors, compression artifacts, poor lighting. There are some kinds of noises are there. So we can remove the noise. So this will be another pre-processing technique. Then data augmentation. For example, we have an image like this. Okay, so this will be the image. Okay, we can augment the image. We can create new images from the existing images. For example, we are cropping this area only. So this area will be a new image with head only, head and okay. So this is another one. Okay, we can zoom the image, zoom out the image, and we can flip the image. Okay, so there are different kinds of rotate the image, crop, we can brightness adjustment, all these can be done to augment the image. So we can create multiple images based on the different features. Okay, so image cropping can be done, so we can crop the images from there. So all these approaches are based on text pre-processing, so to improve the model convergence and reduce bias in the training. Okay. uh, okay, let me give. Let me check for any images. We can do the pre-processing. Let's check for any images. So here the pre-processing include image resizing, horizontal flip, and normalization. All these can be done with a single transform-based library from the Torch Vision. Okay, so we can easily do it. Okay. Okay, so these are the different steps for image pre-processing. So it is not so much important in uh, what using pipeline-based model, but if you are if you are using a normalized picture or image, or if you are using a normal image, pre-processing is important. So that's why I'm just mentioned about the pre-processing, importance of pre-processing. So hope it is okay for you. So if you have any doubts, you can ask now regarding the image creation with the different generative AI approaches. Okay, if you are facing any doubts, you can ask it now. Any doubts? Please ask. I have added a feedback link here. You can add the feedback here. So please post your valuable feedback here. Okay, so any doubts, please ask. Okay, if you don't have any doubts, you can just type clear. Okay, just to know about your satisfaction or know about your understanding level. Okay, if you are satisfied, please type clear. Otherwise, you can ask your doubt in chat also. Any doubts? Have you filled the form? Have you filled the Google form? Okay, if you don't have any doubt, we can wind up. Okay, thank you.